In this lesson, I want to show you how to find the integral of e to the x sine x. So again, let's start with letting u equal e to the x, and the dv by dx part will be equal to sine x. Now I need to differentiate this, so du by dx is equal, and the differential of e to the x is simply e to the x. Now I need to integrate this to get v, and v is the integral of sine x, which is negative cos x. Also, we'd have a plus c for the constant of integration, but we can leave that to the very end. Now popping these into the actual integration by parts rule, we can see that the integral of e to the x sine x dx is equal to u times v, well u is e to the x, times v, which is negative cos x, minus, got the integral of the v term, which is negative cos x, times the du by dx term, which is e to the x, and that's with respect to x. Now let's just simplify this a little bit. So let's take this first part here. We would have negative e to the x cos x. I've got two negatives here, so let's make that into a positive and just swap these over to get e to the x cos x dx. Now the next step is to look at this part here, and again we're going to have to use integration by parts on this part. So let me just do that up here. So we've got the integral of e to the x cos x dx. And we can let u equal e to the x, and we can let dv by dx equal cos x. Now we need to differentiate that, so that's fairly straightforward. Du by dx is e to the x, and we need to integrate to get v. The integral of cos x is sine x. So we have that the integral of e to the x cos x dx is equal to u times v, which is e to the x sine x, minus the integral of v, which is sine x, times du by dx, which is e to the x dx. Okay, let's just rearrange this a little bit. So we've got e to the x cos x equals e to the x sine x minus the integral of e to the x sine x dx. So now we can pop this back in for this over here. So we get that minus e to the x cos x plus e to the x sine x minus the integral of e to the x sine x dx. Now that is equal to e to the x sine x dx. Now if you notice, we've got two e to the x sine x's, so I've got this one here, and I've also got this one here. So if I add this to both sides, we would have the following. We'd have 2 e to the x sine x dx equals minus e to the x cos x plus e to the x sine x. Let me just simplify this a little bit further. So we'd have 2 times the integral of e to the x sine x dx equals. Now we've got a factor of e to the x here, and I'm going to rearrange things a little bit. So I've got a factor of e to the x, and I'm going to put sine x first because it's the positive term. Subtract cos x. Now to find the integral of e to the x sine x dx, all I need to do is to eliminate this 2 here. So if I divide both sides by 2, I will end up with the integral of e to the x sine x dx equals e to the x over 2 times sine x minus cos x. I did forget my plus c there as well for my constant of integration.